Okay, so now we're going to do problem 10.2.24. Here they give us the raw data, and then first they want the regression equation. So I just run the data into StatCrunch, and the test that we use is stat regression simple linear. The x values is given as salary. The y values are given as viewers. You can see the hypothesis test. Both the intercept and the slope are 0. That means there is no correlation. That's the default. We don't care about that. It's just set up the way it is. We just leave it. So we compute, and you can do it one of two ways. You can see viewers is the y, so y equals 5.22. They want 3 decimal places, so 5224, and then minus 0.021 of the salary, which is the x. Or you can look down here, intercept and slope. You can just read them off of here. So the I'm going to write those down. The intercept is 0.522, or I'm sorry, 5.224, and the slope is negative 0.021. They want 3 decimal places once again. So let's put those numbers in. So the first one was 5.224, and the slope was negative. There's an automatic plus sign there, so I have to add the negative inside the box. Okay, so that's the equation. Now, what's the best predicted number of viewers for a television star with a salary of 13 million? Now, right off the top, you're going to think, well, I just put in 13 for x in the equation above, and that's my answer, rounded. But we have to go back and check, make sure that the equation applies, and look at the p-value. The alpha level's 0.05. The p-value is huge. It's not low, so we can't reject the null. There is no correlation. We can't use the equation to estimate it. We have to use the average value of y. How do we do that? We go to data. Stat, summary stat column. I want column 1. I want the I want the viewers, the y values. That's the viewers, and I compute. And the mean for the viewers is 4.8. So 4.8 million is that's the y bar. That's the average. See, because if I plug in 13 for x, I'm gonna get an answer there's no correlation. I can't use the equation. In fact, if we look at the scatter plot, you can see that the equation's senseless. Everything's bunched low, and there's one value way out there real high that pulls that red line way out of whack. That red line does not predict anything, so that's why we can't use it. So is the result close to the actual number of 4 million? Well, not within 5%. 5% is 0.2. It's not very close. Okay. I wouldn't expect it to be close, but if you use the 5% rule, that's probably the best way to do it. Okay, so that's question 10.2.24. And this is Dr. K signing off.